Okay, my friends, we're back. I noticed that if I put the ruler here, it kind of keeps it in focus a little better. And so I'm going to try that. So if you're wondering, why is that ruler there? I'm thinking that's good thing to do. They're asking us to find on 3.4, number 21. This was a question asked by someone in office hours. And so I was putting a video out to them on the answer. So if I'm going to infinity, then this piece here is going to infinity. And this piece over here is going to minus infinity. And these pieces are not exactly the same size, but one's not tremendously bigger than the other. And so one of them's not dominant over the other for the dominant term analysis, because this is the dominant term underneath here would be the square root of 9x squared would be the absolute value of 3x, right? And so that's the reason that I have to, because that's the reason that I have to do more work, I guess, because essentially in my mind I'm thinking about this as being infinity minus infinity. Oh, those almost look like 8s, which is not 0. And we talked about this in class, because this is, since they're not the same size, it could be that this is big minus huge, right? And which would give me something maybe close to 0, maybe not even that close to 0. And so I said not 0. I'm going to say not usually 0. And so this is an indeterminate form. And so what I have to do is I put this as a fraction and multiply by the conjugate. Now, how that changes things for us is if we think about the conjugate, all you do is change that minus to a plus to get the conjugate. If we think about the conjugate, this is something that's big, going to infinity. This is something that's big, going to infinity. If I add them together, I get something that's really big, really going to infinity, right? And so infinity plus infinity is different than infinity minus infinity. Infinity plus infinity is freaking huge, right? And so that's the reason that multiplying by the conjugate is going to help, is because it's going to get rid of that infinity minus infinity part. Okay, what you do to the numerator, you got to do to the denominator. So I do that numerator and denominator. And the conjugate is also sweet because when you do the FOIL, first, outer, inner, last, when you multiply by the conjugate, the outer and the inner go to 0. So all you have to do is worry about the first. So I have not used, that was my thinking here, I have not used anything, any dominant term analysis or anything like that. I've just used, let's think about this for a second. So this is going to be 9x squared plus x, and then minus 9x squared. And those are exactly the same size, right? Because I haven't cut off any pieces or anything like that. So 9x squared minus 9x squared can be 0. So you want to simplify that down. And now I can do DTA, dominant term analysis. What is the largest term in the numerator and what's the largest term in the denominator? And so I almost forgot to move up. I hope I haven't been writing a whole long time without you guys being able to see. I really kind of need maybe an assistant or something. Anyway, so in the numerator, that's x. And in the denominator, for certain, this part can go away at infinity. It's not dominant, which leaves the square root of x squared plus 3x. And we've already talked about the square root of 9x squared is equal to the absolute value of 3x, which is equal to either 3x or minus 3x, depending on if your x value is greater than 0 or if your x value is less than 0. But because I'm going to infinity, I'm greater than 0, right? This was going to infinity. It's greater than 0. So I should be using 3x is what I should be using. And so this becomes, so the square root of 9x squared becomes, under dominant term analysis, becomes 3x, which is the same size as this. So this is not dominant over that one. So I'm not going to ignore one of them. I have to use both of them because they have the same degree. They're both degree 1. And so this is 3x plus 3x. And so this is the limit as x goes to infinity of x over 6x. And the x's would reduce out. So this is the limit as x goes to infinity of 1 over 6, which is 1 over 6. There's other ways of doing that problem, of course. And so if you want another way of doing the problem, go check out the video. If you have a way of viewing the video that comes with the Cengage books, they said that they were making them free. I haven't got my Kevin on figuring out how that I can view those videos for free. I can't even view those videos, and I have the code. But you might be able to, because you guys are really tricky. And Cengage said that you can get an account, and I think it goes 2 weeks at a time on their free account. And this 21 was one that they supposedly have a video on. So you can go look at their video. You can also look at their solution guide and see how they solved it. Anyway, okay, so that sounds wonderful. Talk to you on the next video. I'm making the videos shorter now. I think that maybe will help just be on one thing. Okay, bye-bye.